All right, thank you very much. So thank you everyone for joining. And thank you to Luke and Anthony for joining us to answer all of your questions. So just a quick overview of the tech before we get started. Make sure you're using the Q&A function. You'll see it on the bottom right-hand side to ask any questions of the participants. And if there is a question that you really like that you want to get answered, give it a thumbs up and it'll shoot to the top and we can answer that one as quickly as possible. So with that, I'm going to hand over to Anthony and Luke to give a quick introduction, and here we go. So Luke, shall we start with you?
Sure. Hello everyone, my name is Luke Wagner. I joined Mozilla maybe 11 years ago working on JavaScript engine performance, and then we started a games program to make games run well on the web, and that effort morphed into WASM.js, which was a project to sneakily embed a high-performance, statically typed language inside of JavaScript and add a fast path to the JavaScript engine. And then I worked on that for a couple of years, and that morphed into WebAssembly that we worked on with all the browsers. And then that shipped a couple of years ago. And so since then, I've been working on kind of the further evolution of WASM into more places beyond the browser, which is really exciting. And so, yeah, I guess that's segues to why I'm here.
Okay, shall I talk? Yeah, so I'm Anthony. I worked at Mozilla for 7 years. I started off doing media playback, which was a different branch of trying to kill Flash. So the games initiative was part of that. And then I had the privilege of, actually I met Luke on the street when he was explaining how they were going to get people to adopt WASM.js. WASM. And it was very fascinating hearing that you could, in theory, translate bytecode into WASM bytecode into WASM.js if browsers decided not to adopt it.
Right.
And then a couple of years later, I had the privilege of managing the WASM team for a while. So that's kind of how I got into WASM. I was a fan of it for a very long time, even from the WASM.js stage, and I played with Emscripten before I even joined Mozilla. So yeah, so I'm pleased to be continuing my WASM journey at Tetrate. I've also been involved in Rust since quite early on in that as well. That's me.
Awesome. Well, thank you very much for joining us. And Anthony, I believe you've got a quick overview of WASM for us and a short presentation. So as we're going through this presentation, if any questions pop up, please do submit them through the Q&A function and we can get to them as soon as. Thank you.
All right, let me just push some buttons here. Present. Oh, it's not going to work. No, that's not the right window. Hang on. Okay, can everyone see that? Hope so. Okay, so a brief history of WASM. So let me see. Oh, here we go. It's animated. I didn't know that. So back in 2010, this is before I was at Mozilla. Alonzo Kai introduced Emscripten, announced it in Emscripten, which was a way to compile C and C++ to JavaScript using LLVM. And as Luke mentioned before, that's sort of sneakily because it targeted JavaScript, but there was a way that SpiderMonkey, which is Mozilla's JavaScript engine, could recognize it and sort of compile it more directly. A year later, it seems like Google was working on the same problem in a different way, which is how to bring native stuff to the web. And they did it through a thing called Native Client, which is a heavily resourced initiative to use LLVM bytecode in a way that would run in Chrome. And so a lot of browsers were struggling with that idea because it seemed like it was going to be not really compatible with the web and difficult to secure. A couple of years later, well, a year and a bit later, in 2013, Luke announced WASM-JS as a way to get this Inscripton working really quickly by recognizing it. And even though it's JavaScript, it was a well-defined subset of JavaScript, and you can have a look on the wasm.js.org website to read up more about that if you're interested. But this is really the thing that made it possible and showed that it was possible to actually do this stuff at all, because the performance was, close enough to native that a bunch of games were able to be ported to the web. And then in 2015, this is, and I don't know how to pronounce this guy's name. He announced near-native WASM-JS performance in Edge. So it was good at this time to see that Microsoft was supporting the WASM-JS initiative, and that sort of showed that this was the path that browsers were going to need to follow. So what happened the following year is that because browsers had, I guess, little choice but to follow this, there was enough momentum, and it was clear that there was a path that you could convert WebAssembly into WASM-JS. It was possible to reach consensus amongst the browser makers about what WASM-JS actually was, and there was a lot of it was something that it took a lot of negotiation, I'm sure, and Luke can probably tell you more about that. But yeah, he was able to. They were able to reach agreement and actually ship something that was and it's important to realize at this point it was an MVP, and it was designed to be the minimum you could sort of get away with to get this sort of class of application working. But it still performed extremely well. Sort of later that year, it was noted that the native client had been destaffed, and that Google were no longer working on it, and that it was clear that that WebAssembly was the way forward for the web and for Chrome. And then, that's right, in 2017, chairs announced that, which was some of the people above, but also a different group of people, announced, so it's people from all the different browsers, announced that the MVP consensus had been reached. And 2017, it was noted by Judy McConnell of Mozilla that all the browsers were now supporting WebAssembly MVP. So that was a great moment for the web, because it meant that you could now use WebAssembly and not have to have some fallback path to WASM-JS, as some sites were using. And then in 2019, Lynn Clark announced WASI, which was a standardization effort outside of the browser. And this was actually an important milestone, because up until then, the focus of WASM had been, how to bring native applications into the browser, and also interoperate with JavaScript. But at this point, it was starting to be obvious that there were many uses outside the browser of WebAssembly as a cut down cross-platform platform. Later that year, Lynn Clark also posted about the Bytecode Alliance. She works for Mozilla, which is an initiative with Mozilla, Red Hat, Intel, and someone else. But that
Fastly.
Sorry, Fastly, yeah. And that was it's, which is putting some industry behind WASI. Okay, so I just want to go over what is WebAssembly, just for anyone on the call who is not clear on the details. Firstly, web runs natively on the web in all browsers. Assembly is a low-level language that can be directly translated into machine code. And so even though in most cases WebAssembly refers to a specific low-level language, I think in terms of cross-platform low-level languages, the idea is that it's kind of the lowest level you can get, at least on the web. And I would describe it as a box you can run code in. So it's a container for untrusted code like JavaScript, or perhaps a little bit like Docker, except it doesn't. Docker doesn't have the same security properties, but it's certainly used for containing things. It has a very small footprint, and it runs in process in thread, which makes it good for API access, and that's why it's easy to call from JavaScript, because it runs in thread in process, and it can run code in any language eventually. Now, there are a lot of languages making progress in that direction. I'll talk about that a little bit later. So I just wanted to compare it to a few different technologies here. So I wanted to sort of point out here that WebAssembly has got fast performance. You can do things a little bit faster with Docker, but you don't get quite the same. It's not cross-platform, and you don't get quite the level of security containment. And it's certainly faster and more predictable in JavaScript. JavaScript is fast, can be very, very fast, and WASM.js was a demonstration of that even early on, before they had, even before it was formalized. It has a very, very small footprint, which is what makes it very versatile. You can start up WebAssembly pretty quickly, and you can shut it down pretty quickly. So it's a very good way of containing short-lived things. And then the ecosystem is really based on compiled languages, but it's still evolving rapidly. It's mostly C, C++, and Rust. At this point, a lot of languages and compiler makers are working on various types of support, and there's some issues around JavaScript, but in general, adoption is still early. And I think the key thing here is that it's, it is likely to encompass many different languages in the future. And it's like any new platform; it takes a little while for support to come about, but it has a lot of forward momentum. Some of the reason why, and I just want to go a little bit into why Tetrate and the Envoy community want to use it for extensions, and this is sort of broader than that. But the reason we want to use it for extensions is that it's simplified deployment compared to, say, native extensions. It's got better containment. It's sandboxing, so it's easier to isolate people against making mistakes in their extensions. It's easier to deploy. You've got a greater choice of programming languages. A lot of applications have extensibility, but only in a specific programming language. And for a broadly applicable application like like Envoy, you don't want to say, oh, well, you can only write applications in Lua, or you can only write, extensions in Lua. You can only write them in native C++. In the future, there will be plenty of choice of programming languages. And yeah, there's more opportunities for code sharing. One of the things about WASI is there's a lot of work around cross-language APIs, and so there's also a growing ecosystem around WASI, around WASM and packaging up WASM modules. So that's happening still slowly at this point. So I just want to go a little bit into how it works, because it's one of these things, like anything, it does often help to know how it works. So code is compiled into .wasm files by developers. So WebAssembly is an intermediate representation it's already been optimized by the compiler, but it's not for a specific CPU architecture. So it'll run on mobile or desktop or some CPU that hasn't been invented yet, or some unusual class of CPU it could run on, like MIPS, without having to recompile it. And there's a virtual machine that would run in your host, which would be a browser, Envoy, whatever application. Now, one of the things that I want to talk about here is the way that the code gets generated when you're actually trying to run it. Now, there are different ways of doing it. You can compile it ahead of time, and some companies are doing that. But this is kind of how browsers and Envoy do it at the moment. They stream and compile the WebAssembly code, and just to give you an idea of how fast that happens, it's about 60 to 90 megabits a second. Now, I had to look up some numbers. The theoretical maximum speed for gigabit Ethernet is 115 megabytes a second. So 60 to 90 is actually still reasonably fast. It can be half the speed you can get it across the network. So if you have an already compiled native piece of code, it might take you the same amount of time getting it across the network as it does to uncompress your baseline. So as to generate code for your baseline. So one of the things that is really important about WebAssembly is that memory accesses are restricted within a specific address range. So every WebAssembly module has its own memory, and it's contained within that. And that's really done at a very low cost on 64-bit architectures. The code execution starts using this baseline compiled code, which is not the maximum optimization. It's generated quickly, but the code can execute pretty quickly, given that it's streaming it off the network or whatever, and it can start running it. The optimized compilation happens in the background, and has the same security properties, and then it switches to the fast code when the faster code is ready. And I wanted to explain that just because people are sort of worried about JITs and compilation time, and if you can sort of understand, it's designed to start up really quickly and run at the maximum speed at the same time. I think that's important for people to understand about WebAssembly. What else? Right, that is the end of my presentation.
Proper whistle-stop tour, thank you. We're starting to get questions come in, but please do keep sending them through the Q&A function, and that way we can put them to Luke and Anthony as quickly as possible. Are you ready to dive on into the questions that we're getting asked?
Yeah, totally.
Let's do it. All right, so the first question that we've got is with regards to Envoy proxy specifically, and Envoy proxy and WASM. So this person has asked why Envoy proxy / Envoy WASM is separate from Envoy proxy Envoy. If I wanted to experience with a custom WASM filter, do I start from Envoy WASM?
Yeah, so I better answer that. So the answer for that is that it's still in development, and that's why it's a separate thing. But my understanding is that that's going to get merged in, and once it's ready. So there are parts of it that are not. There are parts of it that are not necessarily complete. And I think once it's kind of deemed to be complete by the developer of that, which is I think he works for Google. I think once that's complete, the plan is to merge that in.
Excellent. And the next question. So most use cases I see for WASM are for stateless applications like gaming. What is being done to enable its use for stateful apps such as databases?
I think there's a couple of things in flight there, because I think one doesn't simply just do stateful. So one specific thing that I saw a while ago, and this was more of a proof of concept, but somebody bolted a WASM engine into, I think it was Postgres, so you could run WASM as your stored procedure language. So that was like one particular way, very different than a lot of other ones. Another way is, I think in general, if we're talking about serverless all over the cloud, is people are still trying to figure out, WASM aside, how to do stateful serverless in general. And there's a lot of things ongoing. So you have, Cloudflare has had for a year or two, kind of eventually consistent key value store in their cloud workers, which can run WASM, so accessible to WASM. And then more recently, actually, I think just like a week ago, they announced like another version that's more like kind of in the virtual actors Orleans direction. Azure has their durable entities and durable functions. So I think this is something, at least from my perspective, it really depends a lot on the host environment where WASM is being embedded. And if we're talking about serverless, from all I can tell, it's still being figured out. But your other thoughts from Anthony on that?
No, yeah, I guess one thing I would say is that I've always been thinking about the fact that the memory itself is just like the memory and the application are separate things, and the host can do what it likes with the memory, so it can store it if it wants to, or it could not, or you can serialize the memory and snap. It's very easy to snapshot the state of a WASM VM.
Yeah, that's a good point. That helped me. It's reminded me of a third approach I saw with Dfinity. They're running WASM on no longer calling it a blockchain. It's now an internet computer. But they'll, their persistence model is the instance is persisted. So, each, as you just stored a memory, you're effectively persisting, that store forever, and different cost model, but because of their context, I think it makes sense for them. So, that's a really pretty elegant model, because you don't even have to think about explicitly storing anything into a database. You just write it to memory.
Pretty amazing. And so then the next question we've had that's come in is, what features are available within the WebAssembly virtual machine?
So many features. So yeah, I thought this might come about. So I had a few different, I had an answer thought about. So I think it was like 4 dimensions of developments of kind of aspects of WASM that we're trying to improve. And so, one dimension is improving support kind of for the existing languages that already compiled WASM. And so on this kind of axis, you've got threads, which are, just about or already shipping in browsers. SIMD, also approaching shipping. Exception handling, or first class support for exception handling. You were able to compile it before, but it wasn't ideal. So actual native support for exception handling, a little earlier down the pipes, or even earlier down the pipe, 64-bit memory, so you can have greater than 4 gigabytes, of memory available to single WASM instance. Multi-value, being able to optimize, be able to return things, multiple things in registers, as opposed to having to pipe all the multiple return values through memory. And bulk memory operations, so you can get really fast copies and other sorts of nice things available for threads. So that's one dimension, is improving existing languages. Another dimension is adding better support for new categories of languages that are not already compiling to WASM for various reasons. So, the big one there is host GC integration, especially if you're targeting the browser. You don't want to ship your whole own GC. Also, if you ship your whole own GC, that GC won't talk very well to the browser's built-in GC. So it's much better to try to use the browser's built-in GC. So how to do that from WASM is a tricky question. So, but lots of active work in the CG at the moment on this particular proposal, and really cluster of proposals. Included in that cluster, also function references, typed references to functions that you can call without a signature check, and tail calls for those categories of languages that, like tail calls, you really want this feature, be able to pop the stack frame at the same time as making the call. So that's the second dimension, enabling new languages. Third dimension, better host integration. So in this one, you have being able to convert between WASM i64s and BigInts on JavaScript. ES module integration, so you can use a WASM module as an ES module, so you can just import it from JavaScript and import JavaScript from WASM using the import statement or import definitions. And interface type, which is something I'm personally working on, which is how do I pass high-level values that aren't just integers in and out of WASM and JavaScript. So that's third dimension. Fourth and last dimension is, my mind, the emerging pure WASM ecosystem, which is the ecosystem that doesn't assume you have JavaScript and the web on the other side of WASM module boundary that says, I'm just WASM, I don't know what I'm running in. What can I do just with WASM? And so in this one, you have module linking. How do I have multiple modules, perhaps compiled different libraries from different languages? How do I link them together? Two, again, interface types, which is, I don't know what the other side is, but I want to give it a string. How do I do that? And then the last one is WASI, which is Anthony mentioned earlier, which is how do I actually access, talk about files and network and other sorts of things when I don't really know what my host is. So these are broadly the dimensions I see WASM improving in.
It leads very nicely into a question I think that we've just been asked in there is how do you view WASI? Is it still a long way in order to achieve what is being proposed?
Yeah, it still has a ways to go. Part of the reason is WASI is actually trying to say, well, how do we define, it's easy to state the goal. It's like, all right, I want a portable OS agnostic interface. In pursuit of this goal, it's actually helped us realize we don't have, especially if we don't assume JavaScript, a great way to define a pure WASM interface that's not very specific to a particular class of languages. So, WASI has to communicate strings. So just asking, how should WASI even pass a string? Is it passing two I32s that are implicitly referencing the caller's linear memory? That's not a great answer, especially in the GC future, especially if you want to change the string, encoding over time. So that and a lot of other also, how do I pass a sequence of things or return a sequence of things? Or any of these sort of basically, how do I make an interface that's language agnostic at all? Motivated, surprisingly, took a long time to get here, but interface types. So WASI took a dependency essentially on interface types, which has sort of made it difficult because interface types itself had to be developed. And then developing interface types, we're like, well, how interface types talks not just about how a WASM module talks to the host, but how two WASM models want to talk to each other. Because ideally, when I talk to the other side, I don't even know if the other side's WASM or the host, because I want to be able to virtualize an API and say, no, you don't get to talk directly to the operating system. You have to talk through me first, because I want to be able to intercept things or mock up a file system or virtualize it or censor it or polyfill or whatever. So I need an interface where I'm talking either to the host or to a WASM module, I don't know. And how does some parent module get to swap in and say, no, here's what you get to talk to? Because there's this capability-based security model also that's a basic principle of WASI, and we want to respect that. So figuring out how does one module link another module and then get linked itself led to the module linking proposal. So WASI, just by this simple goal, keeps spawning other work items, which I think making WASM better and helping firm up the whole pure WASM ecosystem, but it explains why despite fervent efforts by all the people in WASI, it's been kind of held up, and it's fortunately, interface types is coming along nicely. We're almost finished with kind of a big rewrite of the explainer, rebasing it on this linking proposal. And based on that, there's not too much more that WASI needs out of it. So so hopefully it'll start moving along at a more at a more rapid clip once interface types can settle down. But it's understandable that people are like, well, you started with demos that run. Why it's a year later? Why isn't it done yet? And it's like, well, it's stirred up some dust.
Brilliant. And I think we'll head into the next question, which is coming from one of our attendees who's asking, I want to build a full stack web framework with Rust. What do you suggest the front end language should be? This person has worked with Rust, but never with ASM.js or WASM. What do you suggest?
Fun question. Front end language. So this is the language that's going to run in the just to make sure the browser, or sometimes front end means the front end of the server side. And maybe I should know this for more context if I was a more experienced developer. But could I check which one of those two cases? I can answer both. But.
Yep. So if Sitesh, you asked that question, if you want to come back with a little bit more context in the Q&A section, then we can come back to that one and definitely get you a full response as well. So
well, I could just say front end in the browser. JavaScript still a great language. Can talk. Since you're going over HTTP anyways. There's a nice clean language divide. So if you want to write JavaScript or TypeScript or any of 1,000 languages, that's probably what I would use. Rust has a pretty good browser story, but one does not simply write a front end in Rust. Like it's a pretty heavy investment in time and you have very high performance. If you have any performance constraints, I really strongly recommend Rust in the browser. But if there's not like a build performance need, just based on developer velocity and stuff, maybe use whatever you would have used. If you mean the front end of the server, then I've heard good things about the I think it was both Actix and Rocket Rust web frameworks. Both of them I've heard good things about.
I would say just a little bit on language choice is that language choice is very involved because there's a lot of short-term and long-term decisions you have to make, because I think especially if you look at what the ecosystem is like now and you look at what it's like a year from now or 2 years from now, there's no obvious answer to any of it. Like if you look far enough into the future, you should probably write it in Rust. But if you only look like over the next 10 years, maybe not, right?
Once we have WASM GC host integration or GC integration, then I think that's going to blow open the spectrum of languages. So you're going to have really any high level but typed GC language, so like your Kotlin JS could become Kotlin.wasm, or just Kotlin, and Scala JS and Elm and Reason, and there's a whole class of these high level typed, currently targeting JavaScript languages. I think those will be your hopefully the first ones that'll kind of switch over to targeting WASM, kind of as just an implementation detail. So, code mostly stays the same, but that's a few years down the road, unfortunately.
And so following on nicely as well, what would be the advantage of using Rust over C++ for WASM filters?
That's a good question. So I would say I've been involved in Rust since about 2015, and the observation I would make is that Rust is better if you don't have an existing code base, and in fact I couldn't, if I was starting a new project, I would not advise people to use C++, and the reason is that you don't have to deal with certain classes of problems. Now, one of the biggest problems in C++ is it's when you start writing parallel multi-threaded applications that it becomes extremely problematic, and so that doesn't apply to filters, but I would say if you are equally competent in both Rust and C++, you would choose Rust, and if you are more competent in C++, then it's going to help you in the short term to use that. So I guess that would be my suggestion. But I think in the long term, I sort of, maybe I'm an optimist, but I would see Rust displacing C++ altogether. And the thing that I would point out is that 10% of Firefox is written in Rust, and that's changed from 0 in 2015.
All right, so another question that we've had come in is, what are some of the interesting use cases for use cases and projects of WASM and serverless, with the exception of the Cloudflare workers?
So what are the interesting classes or use cases?
Use cases.
Well, they said with the exception of Cloudflare. Also, Fastly's in a similar category as being a programmable CDN with a different take on it, a more kind of WASM first direction, where the actual what's being embedded is a WASM engine as opposed to a JavaScript engine that happens to support WASM. But that, I don't know if that's in the same category as Cloudflare or not for their consideration. That's a good question. Anthony?
I didn't hear the question. So can you ask the question again?
Yeah, absolutely. So this one was specifically related to interesting use cases surrounding WASM and serverless that was external to Cloudflare.
Yeah, the answer is I don't know. I don't.
All right, so another question that's come in is, can WASM replace JavaScript for the web in a long future?
Do you want to answer that one, Luke, or do you want me to answer that one?
Sorry, I missed a bit of the question. It was a can
WASM replace JavaScript for the web?
Oh, that I think I'd be highly dubious of over any time scale shorter than 20 years. I think, the amount of momentum behind JavaScript is just so enormous. And that momentum, even if WASM had all the features I just listed and any of the downsides were mitigated, just the amount of momentum behind JavaScript would keep it going, as there's just a lot of value in an ecosystem that's active and innovating. The way that JavaScript may be implemented may change over time. Over time, especially as the WASM feature set grows, it may become decreasingly silly to run JavaScript on top of WASM. So just as an implementation technique to improve the sandboxing of the browser, you may see JavaScript engines actually internally compiling the JavaScript to WASM. So everyone would be using WASM in that case, and JavaScript would and also in some sense, they're different category, right? JavaScript's a language, WASM's a compile target. So one day it may be the case that JavaScript gets sandboxed by WASM. But just as a language, is it the most, I think the most popular by a factor language in the world, depending how you measure. So that's not going away.
Yeah, so one of the things that I would say just in answer to that question is, I think that there will be a point where WASM technically could replace JavaScript, and I don't think that's that far away. But depending, I mean, it's not 10 years in the future. It's the next few years. But I think, will it ever replace JavaScript? It's like, will Firefox ever be written entirely in Rust? And the answer is probably not. Will Facebook rewrite everything in some other programming language and compile that to WebAssembly? And the answer is no. It's just never going to happen. They're not going to take everything they've done in the last 20 years and flush it down the toilet. But could that whole JS library that Facebook has been working on all those years run in WASM, in JavaScript on top of WASM? And the answer is maybe. So I don't know. That's kind of my 2 cents worth. Do you have more to add to that, Luke?
I would think WASM's most successful outcome would be JavaScript is still a significant percentage of all development and maintains an active, healthy ecosystem, but then there's just a sibling ecosystem, which is just some other language that suits a different set of needs and programmer personalities. Maybe folks who like static types more.
Yeah.
and they can have just as good of an experience and not like a second class. At the moment, WASM's like, it's been described by some as a as JavaScript's x87 coprocessor. It's kind of a amusing initial statement. We're trying to grow out of that one, but there's this feeling of it augments JavaScript in a sense, and that's not always the case when you have these whole script imports. That's not quite the case, but I think that the successful outcome will be you'll be having an equally good experience when you're using like a pure WASM stack.
Yeah. The thing that I would describe it as is to me, WASM represents language choice. And that means that JavaScript is inevitably part of that, right? Because language choice includes JavaScript. It includes Kotlin, it includes Scala, JS, whatever, you know what I mean? Like, that's really, will everybody have language choice? Does language choice include JavaScript? And the answer is, of course it will. So
I love it when they generate conversations like this, and I imagine that conversation is going to continue on for quite some time as well beyond this. So I guess this question I think is split into two parts. So I think the first part is, what are the main differences and benefits of the WASM virtual machine versus the Java virtual machine? And the second part of that is, are there any memory restrictions?
Well, so for the Java virtual machine, that's a question we've gotten for a while now, because in some sense, some direct comparison sense, they both have bytecodes, they're both stack-based. One big difference is that the Java virtual machine bakes in a whole lot more of kind of the programming model and the library sets and what the shape of the languages that run on it are. So it has kind of very much an opinion on this. This is for languages with metadata and objects and things that take a certain shape. And this is the set of libraries supported. So if you wanted to do, WASM can start in a few microseconds and have just, a few K of memory and then be done and gone if that's what you want it to do. So for this filter use case, it sounds like a really good fit. And for some of these CDN use cases, also really good fit. And, stored procedures, lots of things. It would be difficult to imagine Java having fitting into that same kind of footprint because it's just so much more. So I think Java just has much more of the Java virtual machine has just a lot more of an opinion. And so when language is compiled to the JVM, it means they have to kind of, they don't just design their language and then secondarily figure out how to compile it to JVM. They kind of have, if they want to provide a good experience, they have to figure out how does this language naturally map onto the JVM's opinions of what a language looks like. And so WASM starting with, linear memory especially, is just like, I don't really know anything about this language. Here's a bunch of bytes, go nuts. And once you want to integrate with the host GC, well, now some of the opinions start to come in. But again, even in that approach, we're trying to take the lowest level approach, which is like, how little can we get away with having any opinion about this language and saying like, look, there's a garbage collector has to walk over a graph and figure out what's reachable, but that's it. Well, let's not bake in V tables. Let's not bake in the assumption that there's virtual dispatch that works a particular way or anything like that. So I think that's initially how I would characterize it.
Brilliant. And so the next couple of questions are, because we've only got 10 minutes left, this is flying. So when do you think WASM will be merged into Envoy proxy?
Yeah, I have no idea.
We may have to come back and find an answer to that at a later point.
Yeah, I'd have to ask Lijan on an estimate on that. I don't know.
Then we'll get that question to Lijan. And so the next two questions kind of are, what are good projects to get started for someone who's completely new to WASM, but has some prior experience in Golang and Backend? How can they get involved?
Well, if I understand right, Go compiles to WASM and it runs, and there's a team that specifically works on running it in the browser. I haven't talked to anyone with direct experience with that, but as a Go programmer, I would point you in that direction initially and play around with making some things in a browser. It's a nice portable environment that you probably have already and on your system and good dev tools for it. So maybe I'd start with that. But I don't know.
Yeah, so I think I heard some feedback from Go programmers at Tetrate, and that there are sort of two streams. There's the tiny Go, which is too tiny and doesn't have enough things. There's a full Go, which is too full and has too many things. And so I think Go is a little bit. It's not a perfect fit for WASM at this point in time, but it does work. So I think that's one of the things that we are certainly trying to figure out, because I think Tetrate uses Go internally a fair bit. So we want to figure out. We do want to figure out like how to make that work, but I think it's not a solved problem. It's still a lot less mature than Rust and C++, for example.
And so if we take Go out of it, so if anybody has a choice of what languages they can do it in, what's a good and easy way to get started with WASM altogether?
I guess the Rust ecosystem, I think, has had the most ergonomic work on it. There's like a whole book, Rust WASM book. Search for, I think that'll take you to it, and that has a really nice written path that you can follow through. Now you do need to learn Rust, which is not the easiest thing, but I think worthwhile. And it can target both WASM time directly, and there's a so you're running it locally and outside of a browser, and you can check out the pure WASM experience that way, and has a great in the browser experience. So I think that's where the most ergonomic work has gone to. And also you can also get up and running quickly with C++ with mscripten, and that targets very much the browser, but it supports a whole lot of classic C++ libraries, the portable ones, OpenGL, SDL, and others. And so you can get up and running pretty quickly, but it's harder to transition from that directly to outside of, to the pure WASM ecosystem, as far as I know. Might have improved more recently.
Great. Anything that you want to add on to that, Anthony, before we head on to the final question?
No, I think Luke answered that pretty well. He said exactly the same thing I would have said. So.
Fantastic. So we've got sort of 6 minutes left, and this is the last question that we've got in the Q&A right now, which is, there are many models for memory freeing. GC is an older concept. Can we expect I'm guessing that says STH, like ownership model in WASM?
Let me read that a little bit more. Feel free to jump in between. I'm still trying to find that question in the list. Oh, maybe it's open.
Oh, something. Sorry, I'm terrible with acronyms.
Something. Okay, I got it. Yeah. So ownership is memory ownership is an interesting thing. I think up until Rust, people, it seemed like in the software world, had almost decided on the attitude of GC1, get over it. If you're still pre-GC, like, get with the times, are you still writing assembly too? But then Rust was like, actually, y'all, this can be, and the reason for that was, with kind of C and C++, it's just very hard to get ownership correct and not have leaks or use as after freeze. And Rust showed like how to make that safe. And, you have to do more work statically, but it's possible. And then the gains that you see for, when you do when you have explicit ownership, you just don't have these GC pauses, and it's become, I think, kind of a somewhat periodically there'll be a post on Hacker News saying how we took our, got our whatever 99th percentile latency down by switching to Rust, and it was easy, and we didn't have to spend any time. And before, we were pulling our hair out trying to find where's the the leaks coming from, how are these things surviving the generation, the getting promoted into tenured heap, and all that hard stuff. So so Rust has made it popular, but it's at the cost of, the ownership system is hard. It's kind of complicated. You have to learn deal with some serious types. Is there a really simple alternative? Not that I'm aware of. I've heard in C++, I saw there was some efforts to try to kind of overlay a type system on top of C++ to kind of emulate some of those things you can get from Rust. But there's the safe Rust route, and then there's the kind of very simple but error-prone C route of just don't forget, just try your best. Good luck. But I'm not aware of something, and I mean, now trying to enumerate, there's also the Objective-C routes, which is automatic reference counting, and then there's this explicit way to have things survive. And I'm not intimately familiar with that system, but actually from time to time I hear good things about it. I keep intending to learn like intimately what that system is. I don't think automatic reference counting handles cycles. I think it's on you not to make a cycle in those languages because they don't have a cycle collector, which might be fine. Yeah.
Yeah, interesting. Just a note on cycle collection. That's one of the things that Firefox has that's quite powerful. Is that the cycle collection is relatively efficient because you only have to cycle collect on objects that have changed their reference count. But you can sort of look at cycle collected reference counting as kind of a different kind of GC, right? Yeah, I don't know. It's like the ideal thing in any programming language is to express your intent most directly, and it's ideal from that point of view not to have to worry about memory. The problem with memory is that it's not an inexhaustible resource, and how much memory you use actually does matter. And so I've experienced programming in Java and for quite some time, and one of the problems you get is you end up using memory and not knowing about it. And I think one of the things that I would say about Rust that makes it good for high performance applications is that you can't use memory without knowing about it, and for the most part, you're not using CPU cycles without knowing about it. The problem with that is that you have to deal with it if you know about it. And so it's kind of you got to think about the domain, the problem domain you're working in, whether it is worth it to know about memory allocation. Is it worth it to know about every CPU cycle? And sometimes it's not, and sometimes it is. It depends entirely on the domain. And I would say that's kind of one of the successes of JavaScript is the fact that the barrier of entry is really low because you don't need to deal with anything at the beginning. You can just deal with everything later. And that's really what made it successful. It's like, yeah, deal with everything later. Rust is the opposite. It's like, yeah, you got to learn this shit.
And looking back at the question, I saw that the important final part of the question was in WASM. And so initially my answer would just been like, no, that's a higher level. That's like the programming language. WASM doesn't have any opinions. Like, here's a bunch of bytes. You can ask for more. And so mostly that's a programming language concern. However, I think going forward, as we start to like develop this pure WASM ecosystem, you start to say, well, what happens when I have multiple WASM instances and they're dynamically being created? Can I also destroy them? Because if I could, it would be a very clean way, just like when a process exits, it takes all its memory with it. And so here you hear about Unix style GC, which is just don't ever free, the process will die, the memory will get freed. Like, that's actually kind of a beautiful model if you have really short running computations. So I actually have some sort of hope that as the pure WASM ecosystem emerges, we can build up the tools and the things like interface types and module linking and some other stuff for being able to spawn really small short-lived WASM instances that allocate some memory, don't even care about freeing it, and then just die and take it all, the instance gets freed and the memory goes away. So that I actually have some hope for the future, but it's farther out.
Yeah, I'd like to mention actually that there is some like life cycle things, opportunities in WASM that haven't been thought out, right? The life cycle of one module does not have to be for eternity. It can be, I think there's a lot of opportunity there to be able to say, well, we're running this thing for a while, and then the memory and the code are separate, or have separate life cycles. I think there's a lot. Like, I think one of the things I'm really excited about in WASM is that there's so much opportunity that's undiscovered. We will continue, as Luke was talking about earlier on in the session, we're going to continue to discover new things as we try and solve new problems, and as we discover new things, more opportunities turn up to be able to do things that weren't in the original plan.
Brilliant, and we've gone to time. We've covered a whole hour of content. So thank you to both of you, and thank you to all of our attendees as well who've put forward some fantastic questions. From the pair of you, are there any closing sentiments you'd like to share? How people can get involved, or any advice that you give them as they go forward as WASM users?
Maybe my small bit would be, it's actually, even though it feels like it's already shipped, it should be done now. It's still actually, I think, early times for WASM. So I appreciate people's patience and sticking with the bleeding edge, and keep on working with us here as we try to like bootstrap this whole new ecosystem.
Yeah, I'd actually like to just sort of echo that, which is one of the things that I like to say is that the MVP is the beginning of the value, not the end. And I tend to see the potential for things a lot more clearly than some people. And this, I think, is why I've been excited by WASM from the very beginning, because I see what it, not what it does, but what it can do. And what it can do blows my mind. So that's why I'm sort of very excited about finding new opportunities for it, and being able to find problems that we never thought it was going to be able to solve, and applying it to those. So yeah.
And a brilliant sentiment to end on. So thank you both very much again. For our attendees, this has been recorded. We will be putting this on YouTube. The pair of you, you'll be seeing that this will be turned into learning bites and little videos that will be shared across the web as well. But thank you both very much for your time. And to all of our attendees as well, if you want to learn any more, then send an email to learn@tetrate.io or hit us up on Twitter, and I'm sure we can get a response to you. So thank you both very much, and I hope you both enjoy the rest of your day, and same to our attendees.